All right. Welcome back, guys. Welcome back to this new episode of day 4 Solana. This new episode of day 4 Solana. This new episode of day 4 Solana. Try to stay in the system. That's the audience. So, right. Um, let's see. Not this one. Oh shit. Um, Filters. Yep. There we go. Remove this. Okay. Alright. Now we're good. Now we are good to go. Yep. So today we're gonna see the transaction fees. Correct. Alright, so transaction fees. Alright. Every Solana transaction require a base fee SOL to compensate validators for processing transaction. You can also pay an optional prioritization fee to increase the chance that its current leader validator process your transaction. Now the key point is the base fee of the transaction is 5,000 lamports per signature on the transaction. Okay. The prioritization fee, that is optional, is an extra fee you pay to the validators to increase the chance that its current leader processes your transaction. The prioritization fee equals compute unit limit into compute unit price. Compute unit limit into compute unit price. Okay. The compute unit limit is the maximum compute unit your transaction can use. Alright. The compute unit price is the price per compute unit in micro lamports. So it's 1 million micro lamports is 1 lamport. Okay. And the transaction fee pair must be an account owned by system. Right. The base transaction fee. The base fee is the cost of the same transaction. The cost is 5,000 lamport per second, including the transaction. The base fee comes out of the transaction fee pairs account. The base fee comes out of the transaction fee pairs account. Alright. Which is the first signer on the transaction. The fee pair must be an account owned by system program. 50% burned, half of this fees gets burned, and 50% distribution, half of the paid to the validator that process the transaction. Half of the paid to the validator that processed the transaction. Now the prioritization fee. The prioritization fee is an optional fee paid to increase the chance that its current leader processes your transaction. Current leader processes your transaction. SIMD 0096, the validator process the transaction received 100% of the priority fees, and the compute units and limit. Okay. When a transaction is processed, it uses computational resource measured compute unit CU, and each of the instructions deducts from the trans compute unit stage. It uses computational resource measured in compute units. Each instruction deducts from the transaction's compute unit budgets. Max limit transaction can use up to 1.4 million compute units. Okay, the limit 1.4 million compute units CU. Default limit, each instruction can use up to 200,000 compute units. Each instruction 200,000 compute units, and a transaction can use up to 1.4 compute units. That means a transaction can have 1.4 million divided by 200,000. That much of instruction they can use. Okay. Now, custom limit. You can request a specific compute units limit by including a set compute unit limit, set compute unit limit instruction in your transaction. For more detailed compute unit, CU uses compute budget, compute unit consumption calls. See how to request optimal compute guide for more detailed compute. I think it is not so much important for me right now because I'm learning this and I don't have to deal with the fees right now. I mean, I have to, but not right now. So basically, I'll be reading it like on high level. Alright. So the compute price is option CU price. Is an optional amount specified in micro inputs which are paid for each compute unit requested. This price is used to calculate the prioritization fee for programs. That means 1 million of micro lamports is equals to 1 lamport, right? And use this resource to get real-time recommendation on the current price. So the provider, Helios, QuickNotes, Triton. Okay, so they have different priorities. Okay, so right now we are not going for this priority keys. I'll just go to this code here. I'll see what is. So the limit instruction is compute budget program. Compute budget program set compute unit limit is 300,000. Limit instruction and then price instruction is compute this. Set compute price is micro lamport 1. So if I have a connection this, sender this, recipient this, I'm airdropping some of the lamports. I mean one lamport, and then sorry, one soul, and then I'm confirming the transaction using this airdrop and the confirm message, confirm string. Now I'm creating a budget instruction, that is a limit budget instruction, and then price instruction, and then I'm signing this transfer instruction that comes from system program transfer. Oh, basically I'm transferring this thing. God, oh my god. Okay, so yep, so we're transferring the amount from standard recipient with 0.01 sold. Is it 0.01 sold? Okay, so now I'm new transaction, I'm new transaction, and I'm adding all of this instruction here, limit instruction, prices. Now transaction signature is this. If I run this program, if I run this code, I get the transaction signature of this transaction signature of this. So what it says, it doesn't say anything. Mm, I cannot do this. Alright, not a big deal. Now let's read about programs in Solana. The smart contracts. So the programmer deployed on chain to account that contains the program compiled executable binary, and user interact with the program by sending transaction containing instruction that tells the program what to do. Alright. The key points. Program are accounts containing executable code organized into function called instruction. Organized into a function called instruction. Got it, got it, got it. So it's a code, it's a block of code that is instruction, and it's like bunch of instructions. Okay. And while programs are stateless, they can include instructions that create and update other accounts to store data. Oh, 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 oh. Okay, okay, okay. So this is the stateless instruction. That's why it cannot keep the data to itself. So it will make another account to keep the data on that. Yup, that makes sense. And upgrade authority can update program. Once this authority is removed, the program becomes immutable. Uh-huh, uh-huh, uh-huh. Okay, so as we know that the owner can like mutate the program, correct? If you remove the authority, then the program is immutable. Alright, but the user can verify. Users can verify an on-change program account data match its public source code through verifiable builds. Okay, so right now writing Solana programs. Solana programs are predominantly written in the Rust programming language with two common approaches. One is Anchor approach and then native Rust approach, a framework designed for Solana program development. It provides a faster and simpler way to write program using Rust macros to reduce the boilerplate code for beginners. It is recommended to start with Anchor framework. The approach involves writing Solana program in Rust without leveraging the frameworks. It offers more flexibility but comes with increased complexity. Yes, correct. And updating Solana program. To learn more about deploying and updating Solana program, the program can be directly modified by an account designated upgrade authority, which is typically an account originally deployed the program. If the upgrade authority revoked and set to none, the program becomes immutable and can no longer be updated. Verifiable programs allows anyone to check if a program on change code matches its public source code. Okay, so the programs on change matches its public source code, making it possible to detect disappearance dis discrepancies between source and deployed versions. The Solana developer community has introduced tools to support verifiable builds, enabling both developers and users to verify that on-change program accurately reflect the publicly shared source code. Now, searching for the verified programs. To quickly check the verified programs, users can search for a program address on Solana Explorer and ver can view the example of verified programs here. Let's see. Let's see. Let's see. What it's saying. Users can search the program address. Verified program here. Verified program. Verification tool. The Solana verification is built CLI by Ellipse Labs enable the user to independently verify non-on-change programs against published source code and support for verifiable builds. Anchor provides building support for verifiable builds. Details can be found in Anchor documentation. Alright, so we see that the verified builds is program source verified. Verified builds allow user can ensure that the hash of the on-change program matches the hash of the program of the given code base. Okay. Ah, that's kind of makes sense. Okay, so this is the source code. Correct. BPF, Berkeley packet filter. Solana use LLVM, that means low level virtual machine, to compute programs into ELF executable and linkable format files. Executable and linkable formats file. Now this file contains Solana's custom version of eBPF code, bytecode, the Solana bytecode from BPF, and the ELF file contains the programming binary, and it is stored on change in an executable account when the program is deployed. Building programs, the loader program. Okay. Loader programs. Every program itself is owned by another program which is a loader, and currently 5 loader programs exist, that is the native, the V1, V2, V3, V4. These all are loader program, and the loader program has a native loader, a lot of ones, owns the other 4 loaders, that means V1, V2, V3, V4. Alright, so the BPF loader, this management instructions are disabled but program is still execute. The management instructions are disabled but the program Still execute. Okay, it's being phased out. day4 is expected to become the standard loader. Okay, so it's version 2.1.1, version 3, API upgradable. This is loader 4. These loaders are necessary to create and manage custom program deployed on program or buffer, close a program or buffer, redeploy, upgrade your existing program, transfer authority to other program, finalize the program. The loader v3 okay. So loader v3 and the v4 support modification to the program after the initial deployment. Permission to do is regulated by the authority of a program because the account ownership of the each program reside with the loader. Okay. So basically, as the name suggests, the loader upgradable that can change like that can change uh, like modification to the program after the initial deployment. Like they can change after the initial deployment. Version 3 and 4 are the for this. So the pre-compiled program is ed25519 is it has a program ID. Sign verify this. So verify ed25519 signature if any signature fails or error is returned. Alright, so this ed25519 program is that. Signed, it's basically the signature and verify. So the program process and instruction, program processes and instruction. The first U8 is a count of the number of the signature to check, which is followed by a single byte padding, and after that the following struct is serialized one for each signature to check. Okay, so the structure of struct is signature offset. Signature offset 286, signature of 64 bytes, signature instruction index, public key offset. The pseudocode of the signature verification process. Oh my god. Oh my god. That's very long. Okay. So it's having a loop from 0 to count, and then this ith index value referenced. Instruction equal to and transaction dot message dot instruction index is um, instruction index is 825519. Signature instruction dot index and then u16 not u16 max, then this do rust use inline binary operator. Oh my god, what is it? Okay, so basically it is pseudocode. Okay, right? Pseudocode. That's why it's like this. Um, signature instruction index data. Yes, it's this signature instruction index, then dot data, then Again, it has signature offset 64. Then the instruction index. Again, I'm checking this. If not, same thing. Message this. Okay. Yeah, expect 56 KB. Okay, now let's core program. The Solana cluster Genesis includes list of special programs that provide core functionalities for the network. Historically, these were the referred as alternative programs, and they used to be distributed together with the validated code. So the system program, that is program ID of this, create new accounts, allocate accounts, data design, assign accounts to owning program, transfer lamport from system program phone, um, accounts and pay transaction fees. These are things. Instruction is system instruction. Alright. The vote program, that is for this create and manage accounts that tracks validating state rewards. Then stake program. Oh my god, what a programs are there. Config program, add configuration data to the chain followed by a list of public keys that are allowed to modify it. Unlike the other programs, the config program does not define any individual instruction. It has just one impact instruction store, and its instruction data is set of the keys that get its instruction data is a set of keys that get access to the account and data stored inside of it. Alright. Page programs. So these are what? These are the code programs. Compute batch budget. The set computer needs units, limits, and prices for products, allowing them to control computer source and prioritize address lookup table program. PDS. So finally we got a PDS. So basically it is one. So we have